matter occasionally, even when we've just been discussing this kind of thing at Stanford, we've occasionally asked people to turn off the recordings, but I don't think any of the material we have to talk about today is
We have
particularly
permission
objectionable.
in these kinds of contexts to use the images shown, and I have no concern about the technology or proprietariness or anything.
Great, great, excellent. All right.
So is the
Um,
line, or are there other matters to start?
yes, that was my question as well. It would be great if I think we're ready to start. It'd be great if someone wants to take notes on the note page. I'll certainly have my own transcript that I can contribute later. But I think we're ready to go. Otherwise, Caitlin, do you have any other business items? Okay, yeah, and just as a general heads up about the format. Doug is going to give us his expert opinions and experience for probably the bulk of the meeting, and then we'll have time afterwards for discussion. If there is interest and time and other conversation topics come to come to an end, we also have a couple of lightning talks about projects here at Stanford that we could bring up. But definitely, Doug here is the main attraction. So please take it away.
All right. Well, we'll talk about introductions today, just giving you a brief understanding of who I am and my company. We'll talk about a major project that we did with many institutions in the country of Estonia. It was a multi-institutional project. And then we'll turn to the main part that you'll be interested in, is how IIIF and your development and integration and community can help leverage these capabilities to help institutions do better with their collections. So the introductions I will keep quite brief, try to make up some time for my tardiness. I'm Doug. I graduated from OU, go Bobcats. I have two beautiful children, and I am let's call it amateur programmer. My first job was programming in middle school. I wasn't good then. I'm not good now, but it gives me some tools to explore some of the sorts of techniques that we're talking about here. DT, the company I work for, Digital Transitions, is about 50 people. We provide hardware, software, and service for digitization at museums, libraries, and archives. Our systems handle a bunch of different kinds of stuff. I'll spare you from the sales pitch on the specifics, but needless to say, if anybody ever has any questions, concerns, or would like to discuss digitization, hardware, software, or services, we are, of course, glad to do it. So there you go, 30 seconds of introductions. So I want to talk now the main part here about the Estonia project we did, where we learned how valuable AI can be in terms of enhancing collections through faces. The main project here was not the AI face recognition, but was rather the digitization of a large number of film items, mostly film negatives and glass plates, some photographs and some ephemera. But that was across 24 institutions. And I would just flag this as, in my 13 years worth of doing this, it was one of the best examples of intra-country collaboration and joining together of resources and technical capabilities that I have ever seen. I think Estonia should be lauded for this. And if anybody knows of a project starting like this somewhere, they should talk to the Estonians, because I think they did a great job of it. But that means that we had items from different institutions in one joint database at one moment in time, because of course we were doing the service for all of it. For more information about the project itself, the digitization especially, I would point you to a free webinar we did with App from Estonia about the project. So we did 3 different techniques in this project: frequent faces, notable individuals, and data approximation. I think all 3 have relevancy in IIIF. Before I talk about those techniques, I just want to point out, if you don't have a background in photography or film especially, that while we're used to like 1990s photos having very little detail and generally being terrible, if you go back to 1890, actually the image quality is quite good. If you have a large format film or a large glass plate, the level of detail, even on very small in-frame faces, is very, very good. And that's just a quick example of that. So the first thing we did was look for faces. You can't do anything fancy with faces until you determined where and whether and where there are faces. Detecting faces is its own category of AI, and it is astonishingly good. While more advanced techniques like recognition or comparison require more detail and more visibility of the face, the fact that there is a face present is something you can tell even when the person, as you see here under the middle section, is turned away from camera and quite blurry, still says, yeah, there's a face there. By applying face detection and putting some thresholds in place for the orientation or directness to the camera, we came up with about 72,000 faces in the collection. And you can see in the background here, just a nice little mosaic of a relatively small ratio of those. Now, finding faces is in and of itself, I think, a useful attribute or piece of metadata for a collection. It would allow you to filter or search or browse or distinguish or connect images based on, is there a face or not? I do want to point out, face does not mean person, and person does not mean face. So in the motorcycle image here, there's no face, but there's a person. You can also have a person without a face. Sorry, you can also have a face without a person in the case of, for example, a painting or a statue, depending on what you mean by person. Is that in fact a person, etc. Still, in most cases, a face means a person and a person means a face, and those are pretty good pieces of metadata. But this is where things get more interesting because, of course, in modern AI, we can start to cluster faces together. And so we fingerprint each face. That provides a hash or a vector or a fingerprint. There's 10 different names used in different applications. And then we can find close matches to that face. And when we find clusters of matches, we can interpret from that that they are likely the same person. There's, of course, some both skill and art and math involved. But the basic idea is that the fingerprint is based off of not necessarily human understandable attributes, but to sort of take it down to an easy to explain version of this, if we just had 3 attributes, chin strength, and nose height, we could say that this person has a fairly, what do we say for this person? We would say this guy has a weak chin, an average nose, and his nose is quite high on his face. So his dot on that 3 axes goes there. This gentleman, on the other hand, has a stronger chin, a bigger nose, but the nose is not as high on the face. So his dot goes there, and the distance between them would be an indication of proximity or similarity. And if we do this for a whole bunch of faces, we would find clusters around multiple photos of this gentleman or multiple photos of this gentleman where they tended to cluster together. Now, this is the human understanding version with 3 axes and easily describable in words attributes. But of course, AI is using magic as far as I'm concerned, 128 to 512 attributes typically. Each attribute is not necessarily describable in the same way I just gave you, nose size or nose height. They are, again, magic that I don't understand. And using that clustering technique, we could ask for this face, what's the closest match? And this in the collection is the closest match on all, I think it was 256 attributes for our search, the closest match for that face. And likewise, what's the closest match to that face other than the first one is this one. And what's the closest one other than that one? It's this one. And you can see now a great ability to bridge together photos of the same person across different angles, lighting, etc. Now, that doesn't just work. I think anybody who's involved in coding will attest to the fact that if you just put things in and use default values and don't have any human intelligence involved in deciding how to use the tool, you can get weird, spurious results. This is an example of the 12,000 image chain of what is the closest face. And I just picked 6 of them out or 5 of them out. And you can see that, as far as I can tell, these are not at all the same person. But if you just keep going with what's next closest, that's how you get there, which is why we need clustering and not just proximity. So the clustering is done in a field called network graph theory or network theory. And this is a way of taking a whole bunch of data that has a whole bunch of attributes and clustering them in some fancy, as far as I'm concerned, magical way. If you're hoping that I'm going to explain the math behind this, you're talking to the wrong guy. But you can throw all the data in, you can have it cluster, you can manipulate attributes to allow you to be more or less scrutinous, to rely more or less on certain attributes, and you get to a place where it's pretty cleanly clustered. Here, for example, are those 4 faces. I misspoke earlier. It was not necessarily the next closest face. That was a chain of closeness. And you can see that that chain actually kind of spans across a cluster, which is interesting because you can see it's different ages, right? And it's not that the red and magenta are in absolute terms that close. It's that the red is quite close to this part of this cluster and the purple is quite close to this part of the cluster. And that in general, when you apply this magical clustering technique and you get your weights and your attributes correctly, they do cluster neatly together and bridge that divide between the red and the magenta. In the larger collections, the more faces you have of someone, they help to fill in those blank spaces and help to provide connective tissue to each other. And so the confidence and accuracy of the clustering improves. If I only had the red and the magenta, it would be much harder to tie these two together without lowering the confidences to the point where other faces may be mismatched together. So here's an example of clustering early in the process and later after I had refined some of the attributes and toolset settings. And you can see this is a visually driven way of doing this. Of course, you could also look for absolute control cases and develop statistics, but I'm a photographer by training and I do like visual representations of data. And I have to tell you, this corresponded very cleanly to other kinds of checks. Just looking at the data and saying, that clustering does not seem to be very neat here in the center. There seems to be a lot of weird shapes and a lot of weird clustering going on, where here it's neater. But you have to be careful with overreacting to a weird cluster. Here, for example, are sort of a bimodal distribution, if we were talking about like a graph chart, 2 clusters that heavily overlap, but are clearly distinct. And when we look at the images inside of there, when we look at the file names, we pull up the photos, what we find is that those are the same person. They are all Joseph Stalin, and they are all non-live representations of Joseph Stalin, but they are pictorial in the south and they are embossing or 3-dimensional in the north. So statues in the cluster at the top and images, photographs, paintings on the bottom. That's incredibly impressive to me, and one of several points in this project where I went, holy cow, this technology is really scary good. So what are the results of doing all this clustering? Well, we can trace this gentleman, as highlighted, as appearing in 23 photos at the Estonian National Museum, as well as a photo in the Estonian Literary Museum. So if I was a member of the Literary Museum, I would not necessarily know that I could find photos of this gentleman in this other museum in the same country. But with face clustering, I have identified that connection. This gentleman was a really cool use case because you'll see that he is wearing very, very cool and distinctive glasses. And glasses are not, I repeat, glasses are not an attribute that face recognition, unless you go out of your way to enable something or find a weird library. By default, most libraries are not going to use headwear, eyewear, clothing at all. So it serves as kind of an independent real world check that the face identification, the face clustering is working correctly. Is it possible that 2 people with similar faces also have similar distinctive eyewear? Statistically, it's not impossible, but as you're manipulating the variables up and down to cluster in different ways, if you find that when they're clustered too easily, people appear with completely different eyewear, completely different cultural context, completely different clothing on, that's probably indicative of too loose of a match. And when you tighten it down and you find that all the matches feel, in addition to their faces, the context feels right, and glasses can be part of that context, it's a great independent check. And this guy's glasses are so cool. And they let me track that even in some crazy bad photos in terms of image quality of the face, blurred on the left, grainy in the center, both blurry and grainy on the right, it still pops up a very high confidence match for this face being part of that cluster. Which again, another part of the kind of scary good, which is a topic worthy of discussion. Not the topic I'm currently discussing, but it's scary good. I mean that both in that it's good and that it's scary. And then there is the photos, and I don't want to get too glowy or sentimental about this. I'm not a curator. I'm not a conservator. I'm not a narrative storyteller, but I'm a photographer and I am a human being. And looking through this person appearing in these completely different contexts, finding them with their military service and their work, and it kind of makes you remember that all of us are like this guy, right? All of us have these different faces we wear in different contexts, and that we are different people across time. This gentleman clearly served during wartime. So there was undoubtedly in his mind, before the war, during the war, after the war, context of his life. And to track him so easily in a historical archive with his face serving as his fingerprint of connectivity, it's beautiful. And it works really well. Here's another example. This gentleman appeared 16 times in the Art Museum, appeared 10 times in the Literary Museum, and 1 time in the National Museum. The appearance in the National Museum, this is not a bug or a fake. This is what the algorithm returned, was a painting of him. And using some other context here, you can determine with very high confidence, yeah, that's that gentleman. So that's Ans Lipman, and you'll notice the image on the left is in fact labeled with his name. Now, this was unfortunately for me not a huge discovery because this is a known individual in the context of the culture and the time. But if it weren't, if he wasn't otherwise notable, having a name on one image in one collection has now given us an extremely high confidence indication of the identity of the people of this person in this collection and of this painting in this collection. Like any automated source of metadata or any AI process, I would not trust it with 100% confidence with no verification or skepticism, but it's a much better starting point than, I don't know who that person is. No idea. Here's an individual, again, coming from group portraits, appeared in a whole bunch of group portraits. I believe these were class portraits of various kinds or group portraits of various kinds. And you can see him appearing, and again, with photo collections specifically, and especially early film, where film was almost exclusively done by high-end professionals doing it for their livelihood and having learned it as a technical skill with deep and also, not for nothing, each picture cost a lot of money for them to do in both time and resources. The photos are good. The quality of the image is high. The quality of detail on the faces is high. So these kinds of early plate collections carry really high value for face detection. You can see this individual appearing across many different institutions in different groups. And by the way, especially with the group portraits, we'll come back to this, but the ability to then interconnect other individuals in these photos using him as a link is extremely powerful. So one last one I just want to show off, because stage makeup, stage apparel, unusual costuming, these don't really affect AI face detection that much as far as I can tell. I don't claim to be a deep expert, but from a practitioner perspective, boy golly, it picks up people wearing weird thing. Let's not say weird, that's judgmental. Unusual, atypical, out of normal day-to-day life face makeup and clothing has no problem picking up and linking with high confidence. And again, the protest images on the right and stage images on the left are not necessarily images I think that you would look to find the same person in. And then finally, one of the best indications of someone being picked up outside of their context, we have from the Museum of Veruma, the stage collection. This individual appears a whole bunch in various outfits and makeup. And then once, and only once, in the Estonia History Museum, in what seems to be a social gathering, which, from context and the number of times she appears, which is one, doesn't seem to be a celebration of her. It doesn't seem to be related necessarily directly to the stage. I don't know that with definitiveness, but it seems to be a context, another part of her life. And whether that's specifically true here or not, I know that it would pick up, right? Because it's not biasing based off of likelihood in the image. It's not biasing based on proximity within the physical collection. It's just saying, does the face match? And picking up someone outside of their known context could lead to a lot of potential discovery, a lot of potential value. And then lastly, the single most surprising find, the face detection came back and face clustering placed these two faces extremely close together. And I thought things were broken because it's not a hyper realistic portrait, right? The portrait of was it Lars, the other gentleman, I feel like the style of that portrait was fairly highly realistic, not ultra, but you get my point. This is a stylized portrait, and yet it's still picking up the face as being close enough to flag a potential match. And I thought it was a false positive. And I was about to adjust my clustering when I said, let me go look at that set of images. When you find the gentleman painting that portrait right next to the woman in question posing in front of the portrait, followed by in the bottom center, a photo of her sitting at the round table with the flowers, presumably sitting for the portrait. I'm going to go ahead and say that's a highly conclusive context clue that that's the right person. And that's astonishing to me. So all in all, we came up with a bunch of common faces. I don't think necessarily the only value is in the ones that appear most often. I think that's the lowest hanging fruit. Hey, across 24 institutions of Estonia, these are the faces that appeared more than a couple dozen times. The obvious ones are not going to be, again, big discoveries, but they're still useful to label in terms of metadata discovery, filtering, linking images together. And I think as you get down to the appears frequently, but not overwhelmingly, I think you probably do find a lot of individuals who are not known or notable and whose place in history, ability to see the connective tissue of their life would otherwise be completely obscured by scale. Because remember, we found 70,000 faces across 100,000 glass plates. Even someone with an astonishingly good memory, lots of arduous research gumption, they're not going to be able to do what AI does in that context, let alone my later suggestions for bridging this across millions of images. The other technique we applied was notable image detection. This is using an off-the-shelf commercial engine. In this case, we used AWS, Amazon's recognition service. And notable face detection works off of that existing database of faces with identities associated with them and can identify, for example, apologies to anyone Estonian, my pronunciation, Konstantin Pats. And also, depressingly enough, of course, Stalin and some of his cronies. We've also previously used this technique in the Smithsonian collection and identified various singer-songwriters, performers, actors, etc. And it is useful. However, it's not very inclusive. It's not very diverse. And I mean that in the both political and like literal statistical sense. It's very biased to modern images and images from entertainment-based collections, because who do we have for Amazon AWS to pull down 1 million photos of? American celebrities, teen bop stars, right? So it's moderately Western biased, heavily modern biased, and lightly biased towards entertainment, as far as, again, as I can tell as a practitioner. Of course, as any of these APIs evolve every week, I could be a month out of date in my knowledge of it. Maybe they've suddenly uploaded a whole bunch of early 19th century European political leaders. But that is going to be the natural tendency of these engines, is based on the kinds of data they can easily access and have pre-labeled, it's going to be very biased. And so as a result, when we look through the Estonian collection, we find random matches that are completely spurious and false positives. Lucky Diamond Rich, a very heavily tattooed individual born in 1972, appears as a very high confidence match for an Estonian sports star on a glass plate from, honestly, don't remember the year, but way earlier than born in 1972 to be appearing that age. Or a modern actor or actress, very likely to find matches there as opposed to older individuals. Now, we can get rid of a lot of this because we can estimate an age. One of the attributes of most face recognition software or toolkits is to estimate an age. And here you see, for example, the automated estimation of that gentleman that I showed earlier, and you can see his span of life that was documented here. Again, estimations, could this actually be 30? Very unlikely, but not impossible. Could this guy actually be 30? Very unlikely, but not impossible. But the estimations are generally labeled with confidence, and I generally, from my practitioner experience, trust that that range is pretty accurate. If, for example, the collection range is known, then you can say if the person plus their age lead to a match that would not lean up to the time, you can reject them as a false positive. So clearly, a teen bop born in 2000 in an 1800 to 1900 collection is a false positive. If you have, instead of a collection level date, you have a date for the box or the image even if it's just a range, right? The box was photographed in the 1870s. That's still very powerful for removing these false positives from these commercial database matches. And using that technique, we did find a good number of individuals. Again, despite the modern bias, despite the Western bias, despite the entertainment bias, we did find some good matches. We also found some false positives and some ones that I couldn't personally verify, but some interesting results there. But commercial off-the-shelf databases, I think, are not our collective community of archives path forward. They're easy, but they're not good, and they're especially not good in our context. Which brings us to my suggestions to IIIF, which I submit extremely humbly and with a full disclosure that while I am aware of IIIF, I have read through explanations, I have sat through some presentations. I am the opposite of an expert in IIIF. I think I understand your purpose enough to speak to you, but certainly not the technical underpinnings well enough to know if the things that I'm pointing to are already done, possible, of interest. I don't know. Anyway, with those caveats said, what do I think? I never am shy to share my opinion. I think that IIIF should allow face-specific ROI tags. So I know you can make a marquee, you can make a box, a bounding box, and label it in IIIF. I think that should be able to be labeled as a box defining a face. Even if that face is not known to be a specific person, and if the only label is face, I think that creates a lot of potential value. I think that allows you to extract automatically the faces of another collection and look for matches against yours without downloading the entire collection, which is both good for you and the people hosting that collection, especially when we're talking about group portraits and the bounding box is 100 by 200 pixels out of a 20 megapixel image. You might be downloading 1%, a tenth of a percent of the total file size. When it comes to face prints, the different software that is used for this technology makes an embedding or a vector or a face signature. At the end of the day, whatever you call it, it's some sequence of numbers that is their way of saying the face looks like this. It's the computer speak equivalent of he's got a tall, skinny face with a high nose. I think I just described myself unintentionally. I didn't even mean to do that. The face print itself is typically very small. It varies, and I don't consider myself an expert of all the technology out there, but I'm looking at options that are half a kilobyte to a kilobyte or two are fairly large face prints. And I don't see any reason why a IIIF embedding of that in the metadata to make accessible to say, what is that specific face? Again, not identifying the individual yet or at all, but saying this is a characteristic of that face would save people from downloading the image of the face and running their own clustering on it. You could, if you know the technology used to make the embedding, and you run that same technology on your collection, directly compare the metadata, skipping the image entirely to say, are there other faces similar to this? And then once you find those potentially similar faces, have a programmatic download of this small face. And then if you want a programmatic download of the entire image in which the context of that face is provided. I think that would give a very powerful tool for institutions to look across collections. Now, once we get going, right, whiz bang, everybody's done this. We can search across 100 institutions programmatically. People are going to start to discover and label faces. And this is an area outside my expertise, but I do know the concept of a naming authority would allow for some definitive and structured version of that name to be linked to that face print with, I think, some level of confidence should be associated with that. So that as an institution, you can say, we're going to say high or medium or low confidence that the face involved is this individual. And when you say this individual is a link to a naming authority for that individual. So we're talking about the same John Smith from 1875 as opposed to some other John Smith. And then lastly, most complexly, and I think most powerfully, I think IIIF should jump on the potentiality to provide for sophisticated labeling of dates that are uncertain. And again, I'm not an expert in IIIF, so at the end of this, and when I ask for comments, somebody might pop up and say, Doug, we already do this in 5 different ways. But I know that circa 1970 is not a sufficiently programmatically extractable and meaningful statement to do what I'm about to show you. Konstantin Potts, detected with extremely high confidence to be this individual, and with moderately high confidence that he's between 53 and 61 years old as pictured. That infers this date of this photo is between 1927 and 1935. Again, not 100% confidence, more likely to be in the center than the fringes, not impossible for it to fall outside of the range, but a good confidence interval of 1927 to 1935 based on no information of the image whatsoever. But it gets better, because here on the left, the photo date is already known. There's metadata in the system. It was written on the back. There's a timestamp in the corner, whatever it is. I guess not a lot of timestamps, well, handwritten timestamp maybe in the corner. Photo date is known to be 1910. I don't know who this person is, but they're estimated to be 52 years old, plus or minus 4 years. They appear again in a photo that has no date information, no identity information whatsoever, but we can infer that that photo is around 1904. We infer that because the face that is the same is estimated to be about 6 years younger. The interval of that confidence is plus or minus 4 years. Before we even think about doing advanced statistics, because these companies don't disclose and there's not as much confidence here on what the bell shape looks like, if we just add them, which is the most pessimistic possible way of doing it, we would add the 4 years of uncertainty to how old he is on the left, to the 4 years of uncertainty on the right, and we'd be able to infer the photo date there as being 1904 plus or minus 8 years. Now, that's not hyper precise, but if we had no date information whatsoever for that photo, that is very valuable. So you can imagine now if that person appears next to her and she appears in another photo, and they appear next to some other 4th person, and that person appears next to a 5th person, we can still follow that network effect down the line, down the chain, to provide some date confidence across a large number of photos, because people are social individuals. And of course, I can't speak to every collection of photos in the world, but a lot of collections of photos show more than one person in the photo at a time. And if you start with 100,000 images and you only know 20 dates on photos and 30 names and people, I would not be surprised if you could get to 20, 50, maybe even 75% coverage of the collection to have some meaningful plus or minus a few years date inference. And that is extraordinarily valuable when we often are talking about collections pictorially that were stored in some box, pulled up. We have almost no information about it. And if somebody wants to search it, they're basically looking through a photo at a time for 100,000 photos. So there you go. There's my suggestions. I wrote, along with Hannah Storch, Decoding Pictorial Collections Using Faces, a draft of which was actually not a draft. It is the published pending publication version. Please don't repost that until it is fully published, but feel free to, of course, buy the corresponding publication, Decoding Cultural Heritage, a critical dissection and taxonomy of the human creativity through digital tools by Springer Publishing. And of course, if you would like any other information about me or my company, of course, I'm also glad to be reached out to. I'm easy to get to. So I'm going to go back to the IIIF suggestions, and I'm so eager to hear from you guys. How far out of the loop am I on what you can already do and what you guys have already been talking about and thinking about at IIIF?
Great, great. Thanks, Doug. Yeah, that was really really amazing presentation. Very impressive. Yeah, I find it very impressive what you've done with the Estonian collections in particular. And yeah, it'd be great to get people's comments and other comments and questions. We didn't have time for introductions at the beginning, so just anyone who wants to talk, feel free to introduce yourself if you like. We saw some good comments already in the chat. Most recently from Diego, who has some good points about that you'd want to include. Ideally, we'd also include metadata about the source of the face vector, and then the techniques used to match them if we're doing matching. That kind of fits into the general push to have it.
And I will say, of course, I think anybody working with AI is very familiar with the problem with the models themselves are shifting so quickly. And if it's any commercial API, you may not have access to the older API. So that is a major issue, and certainly worth making sure that the method API model version settings are included in the metadata where practical. Certainly the face print from one service may not have anything to do with the face print of another, which is unfortunate, and one of the reasons why the bounding box by itself, I think, is of pretty high value.
Those are all really good points, Doug, and thanks. I saw some of your presentation. I had to participate in another meeting earlier, but I have read the piece and heard really good things about your presentation from my colleagues. I'm Peter Leonard here at Stanford with the other Peter, and as well as with Emma. One thing I wanted to ask you was, first of all, I think a lot of the points you're making make a lot of sense. It is striking how these just a small compact set of NumPy arrays, or even an average set of NumPy arrays over hundreds of images of the same individual, can be a stand-in for identity, both for good and for ill. It's interesting to think about. I was curious, you had brought up this point about the cloud-based models, Amazon Recognition, Google Cloud Vision. I'm sure Azure has some brand. I was curious if you're using those cloud-based models for face detection or feature extraction, or if you're running something locally on premises or in your own cloud for reproducibility reasons.
So I did local models twice and had quite good results. For various implementation and expediency reasons, we ended up using AWS Recognition's face printing for the final deployment. I would say that based on not being a deep expert of each of the three that I used, they all performed fairly similarly. But there is something very nice about not having to worry about infrastructure and dependencies and maintaining anything besides here is image, give me fingerprint. And so in the end, we did go with the AWS solution for that. I'd also flag the ethical concerns you brought up, and I mentioned only in passing during my presentation. I have 2 young kids, and I'm very deeply worried for them about ongoing use of AI in modern cultural contexts. I think it's going to be potentially catastrophic to human society. So I don't underplay that. Of course, I'm much less concerned personally, and I don't consider myself an ethics expert or a collections expert, but I'm much less worried when I'm looking at photos of people who were born in 1850 and who are part of a public collection where you could look at their face anyway, and the number of photos they have is not billions and trillions, but certainly a thing, right? And yes, of course, AWS does you can purge that collections-based fingerprint as a command, but you do have to do that. You have to clear your, essentially not cache, but your collection of them.
Yeah. One thing that comes to mind in some of our, or in my own just sort of very initial exploration of this space, is that we think of these great portraits of like one person's face, or a great staged photo where you have 5 people sitting behind a table and everybody's face is roughly on axis, not more than like 15 degrees off. You also think of photographs in which an individual is present, but their face isn't. So imagine somebody shooting like Nixon and Kennedy from behind in the first televised debate. Well, Nixon and Kennedy are obviously the subjects of that photograph, but there isn't really a face. And if you did say, hey, this is their head, you'd be feeding complete junk into your averaged, vectors. So it's an interesting problem around how to, it's almost like you don't want to tightly couple the notion of a photographic identity with a front-on bounding box. If it's too tightly coupled, if that's your only software or UX apparatus for indicating presence, you can get in some situations where it's sort of overfit to the sort of I would say majority of the case, but not all the time, where the face is front and center. But I think about this mainly because I do believe, and I think one of the ideas you were discussing, which was that how can our museum or archive or library systems represent presence. I've been impressed by what I think Cornell University has done with I think they have a similar software platform to Stanford's system, but they've even gone so far as to incorporate linked open data into kind of user interface affordances of like, this book is by Einstein or this book is about Einstein, right? It has that notion of like, am I the author or the subject or whatever? And you can imagine a world where that software layer was showing photographs and saying that there is an individual who we know who maybe has a Wikidata page or something better than Wikidata, and we can represent that this person, at this time was in this photograph, and just show a little thumbnail, right? And say, these are all, now show me all photographs where we have like, we have Weird Al Yankovic and Michael Jackson in the same picture, right? That's a way of browsing an archive based on identity that I think would be really exciting to at least explore.
Mm-hmm. That's a very interesting notion, especially the linked open data. Obviously, this is a great feeder for that, but it is the linked open data that is of value, not the fingerprint, right? It is the ability to encourage and enable that linked open data, not the data itself. Nobody cares what your fingerprint is.
There are, it was interesting to me, and I don't want to keep talking, so please, everybody else just break in, but it was interesting to me that you touched on probably one of the least sensitive areas of demographic analysis, which was age. And it was useful in the sense of, hey, we think we can date this to 1910. A lot of these libraries have other features, which I think most people on this call wouldn't touch with a 10-foot pole. But what it is really creepy to go through something like Deepface, which I think wraps like 6 or 7 detectors and 6 or 7 embedders, and to find in that code in 2024, and again, some of this is the daughter libraries, not the main code, but to find racial classifications and stuff like that. And so you always have this sense of like, what code am I touching and what assumptions are there? Again,
to flag, you had put some interesting, or someone had put some interesting articles to that effect in the reading notes or the pre-meeting recommended reading.
Right.
I did find that, I mean,
yeah, it's always
coding, especially when you're talking about open source, is often scary as to what can end up in the code base, whether it's malicious,
right,
unintentional, or ancillary. Yeah. There's often stuff in there that's not what you were asking for.
Right. It's like, I feel dirty just touching this code, but it's useful, right? And so one project, I think, if there's anybody on this call from the Smithsonian, I would happily defer to them. But the late Effie Kapsalis was working on women's history in the Smithsonian Institution. And I actually don't think she touched gender, but I think she was working in women's history. I don't know if she used gender classifications in Google Cloud Vision, which is, I believe, what she was working with, or her team was working with. But the reason I bring that case up is that people have worked for the Smithsonian, women have worked for the Smithsonian Institution since it was founded, but they were rarely documented. Their careers were rarely documented. And so I think one of the things that motivated that team to tell women's story at the Smithsonian is, if you're going to do the deep dive on one person's story, find somebody who isn't attributed, but who's present in a lab photo. If you tell her story, you then want to find other images of her face within the Smithsonian, so that you can see in another photo where she isn't documented, you can say, well, this is probably the same person. We can check the archival context. We can validate our guess. But that was an interesting case of facial detection and recognition being deployed in an archive around questions of gender, and not to my knowledge making use of a gender classifier. But of course, that would be one way of finding images of women in the Smithsonian, would be to touch this code that I've never touched because I am not confident in how it was trained to find those kind of representations in an archive.
I mean, I think I would flag that I am doing a presentation with Julie McFay from the National Geographic Society at the upcoming IS&T Archiving Conference in DC. It's a short course the day before the main conference on, I believe we called it Can and Should AI Do That?
Mhm.
And it's specific to the context of cultural heritage digitization and the kinds of questions like, is it going to be good, capital G, effective and affordable to search your collection for that same underrepresented individual across the rest of the images, is the kind of thing that requires a lot of thought before you get started, at least before you invest significant time and effort. And Julie has come up with, I think, a very good flexible framework for that evaluation. And that is the crux of our presentation. I'm doing a little bit on the technical. Most of the presentation is her ethical, moral, institutional, political, legal, public relations framework for should we do that. You know, the Jeff Goldblum, your scientists were so obsessed with can they didn't consider should they.
Yeah, right. AI finds a way. The other thing that kind of comes to mind in listening to what you're thinking about here is the notion of just, it's useful for all of us on this call and everybody in IIIF to think about how different computer vision systems see. One of the experiments I did a couple of years ago, which I looked for actually a live web demo, and I can't find it, maybe for the best, but we used a face detector to clip out several tens of thousands of faces from a large archival photo collection. And then we projected those faces, just the face bounding boxes, in like the semi-final layer of an ImageNet solver like Inception or something. And then we compressed those using UMAP to 2 dimensions. But then we did the same things with a 512 final layer of, I think, FaceNet V2 or something. So we had 2 embeddings, 2 projections in 2 dimensions. One of them was what a non-facial aware computer vision system saw, which was like this ImageNet captioning thing, although we were 1 layer back. And then the other one was a compression of the 512 facial dimensions, the uncomfortable sort of anthropology, phrenological dimensions. And what's interesting about but visualizing this, we put it in a WebGL engine so we could visualize motion between FaceNet and the semi-final layer of Inception. And what's interesting is in Inception, what you get are non-demographic characteristics. So everybody wearing a wide-brimmed hat, everybody wearing spectacles, eyeglasses, sunglasses, everybody with a funny collar or a strange hat, clustered in ImageNet because it's just looking at the semi-final layer, it's just looking for broad patterns. When we shifted the projection to FaceNet, depending on your collection, you got sort of demographic spreads. And part of this is the dimensionality reduction algorithm and the sort of random nature of that. But so in one large collection of European photographs, we got like old women in the top left and younger boys in the bottom right. It's just like, it's random every time. I know from looking at a diverse set of collections in that if you aren't careful with those types of projections, you will end up with like unfortunate clusters that probably don't map to the way most of us think about the world in 2024. But it is worth just keeping in mind how different computer vision systems see. And there's something wonderful and terrible at the same time about these facial recognition systems, which seem so adept at pulling out aspects of the head that really do belong to a long discredited branch of science.
Well, connecting those to individual attributes as opposed to the physicality of the face, right, is I think the distinction there. I would hope for practitioners. I wonder if, because I do notice that Greta Vasula, I apologize if I'm misspeaking your name, but I don't want to put you in the position of representing all of Estonia. That would be wildly absurd. But I do know that, of course, you do have some connection to these collections. And I've spoken now at length about a project to work with those collections from a technical side. I wonder if you have anything to contribute on value or history or context or things that I totally messed up in my explanation, given that I don't claim any expertise on Estonia or its history.
Hi. No, I think you gave a very good and interesting introduction to it. Actually, I didn't know about the project, so it was very, very interesting for me, and I have to contact up and ask about it. But actually, we yeah, it's we can also in Estonia we have a sort of AI tool that is developed by our National Heritage Board called Folli, that also tries to do facial recognition with images. It's not IIIF compliant, and but maybe one day it will be. But yeah, it was my, and your pronunciation of Konstantin Päts was almost perfect, so very good.
And my pronunciation of your name for my own reference.
Almost very good.
Thank you for your generosity of evaluation, if nothing else.
You're welcome.
All right. We just have a couple more minutes, but if for the scheduled time for the call, yeah, but if anyone else has any other questions, please bring them up. I'll just make a general comment that thanks for the suggestions about IIIF integration. It'll be great to see those in a publication, especially. I think people have mentioned there have been various projects using various computer-assisted annotation techniques that do then integrate the results into IIIF at the annotation level, and that's definitely something that can be done with face detection and potentially identity resolution data. I think we touched on some of the important considerations to bring up about exposing where the model came from, where the matching approach came from. But yeah, that's there aren't any technical hurdles to that exactly within the annotation system. I'll mention that just to short circuit the lightning talks that we were going to bring up if we ran out of time, which we didn't, unfortunately, or if we ran out of other things to talk about. That with the software, my experience has been that the detectors work really well. The embedders, the feature extractors to give you the face fingerprints work quite well. But there is kind of some magic, or some actually more like a real work necessary at the clustering level, especially if you're doing just unsupervised cluster, well, basically unsupervised clustering, where you don't have reference images of the people you're looking for, or reference face fingerprints of the people you're looking for. That's where real kind of data science elbow grease seems to come into play still, at least in my experience. And it seemed like that was kind of the case for you. Like, actually, it helped to actually visualize the clusters and see how well they were cohering.
And it is helpful. I did do some ancillary cleanup and automated checking using proximity in the collection, because obviously two photos next to each other in number within a folder, within a box, within a shelf, within an archive, within an institution, if they show the same face print, that is more likely to be a true positive than a false positive. So there is some context specific automation you can do, but yes, there's certainly certainly an art form and a lot of, frankly, elbow grease, as you say, in cleaning up and setting where you need. And also, we never got to it, but if you intend on using the data in way X, you might want to be more scrutinous. If you're revealing it to the public, if there are cultural or time specific sensitivities, you may want to only have a very high confidence match shown. In other contexts where you're just saying, I'm a researcher, I am academic, and I want to see every possible match, it's a very different threshold. So I am not an expert in how to deal with that at the implementation level, but certainly there's what question are you answering that's involved.
Yeah, great. Yeah. Thanks for bringing that up. Yeah, totally agree with with all those points. It definitely resonates with, I think, the experience we've had, with the experience some of the other folks on the call have had. And I think it'll be great. Hopefully, we can all take this experience and continue to improve our facility with these things, and spread the word to other people who are interested in these approaches. All right. Well, so we are over time now. So again, Big thanks to Doug for being the main event in this call. It's really useful for me, and we'll have the recording and the notes to share with others as well. Yeah, and I think that's all. Unless anyone else has anything else they want to bring up.
Thank you for your time.